Now see here, next topic is refraction of light. What happens in refraction of light? You know, the light goes from one medium to another medium. So when light travels from one medium to another medium, its path changes. So this phenomenon is known as refraction of light. See, suppose you have taken any, this is the interface of the two media. This is medium 1 and medium 2. This we have taken comparatively a rarer medium, and this we have taken a denser medium. Now there is a normal, and at this point here, suppose the incident ray is coming like this, and this is the angle between incident ray and normal at the point of incidence. So this incident ray goes into the another medium. As it goes into the another medium, it bends towards the normal, and this one is known as angle of refraction. If you are taking, this is reverse one, if it is going from denser to rarer medium, so after refraction ray will go away from the normal. So this phenomenon of the light, when there is a change in the path, when it travels from one medium to another, is known as refraction of light. So see here, during refraction of light, frequency of the light does not change, as well as phase does not change, but its wavelength and speed changes. So there are certain laws of refraction of light. So laws of refraction of light. So now see here the first law, incident ray, normal at the point of incidence, and refracted ray all lie in the same plane. This is the first law. And in the second law here, the ratio of the angle, ratio of the sine of the angle of incidence to the ratio to the sine of the angle of refraction remains constant for a given pair of media. So we can write here sine I upon sine r, this is the sine of angle of incidence to the sine of the angle of refraction. It is remains constant for the given pair of media, and that constant is known as the refractive index of the medium. So we can write here mu 2 1. So refractive index of the second medium with respect to first is equal to sine I upon sine r, and this one is known as here refractive index of second medium with respect to medium 1, and this one is also known as here Snell's law. So this is about the Snell's law and refraction of light. So now we have done Snell's law, and we have seen here mu 2 1 is equal to, that is refractive index of the second medium with respect to first is equal to sine I upon sine r. Suppose you have taken, in this case, mu 2 1, refractive index of second medium with respect to first is greater than 1. It means that is I is greater than r. That means that when the light travels from one medium to second medium, it bends towards the normal. This is the first case you can take. In the second case, if you are taking mu 2 1 is less than 1. So if mu 2 1 is less than 1, it means obviously r is greater than I. So we can write here r is greater than I. It means when the light travels from medium 1 to medium 2, it goes away from the normal. So this is about the Snell's law, and also see here we can write the refractive index. Suppose you have taken medium 1 and medium 2, and suppose medium 1 is here, we can take air, that is called also free space, and here the light is coming from here, angle of incidence I, and this is r. Here speed of light is c, and in this medium speed of light is v. Then also we can write refractive index of the second medium, that is mu 2 is equal to c upon v. So when the light is going from medium 1 to medium 2, medium 1 is air, then the refractive index is actually here defined as the ratio of the speed of light in air to the speed of light in the medium. And also we can write for the another medium, if you are taking another pair of medium here, like here mu 1 you can write suppose c upon v1 also, c upon v, just to take mu only. So we in general we can write here now mu is equal to c upon v. Suppose you are writing mu 2 1 is equal to mu 2 upon mu 1, that is a refractive index of second medium with respect to first one. It can be written in this way, and here it can be written C upon V 2 upon C upon V 1, and here this will get cancelled. So, you will be getting mu 2 1 is equal to V 1 upon V 2. So, we can relate refractive index with the velocities also here. So, generally when we get like a refractive index of glass, it means that is a refractive index of glass with respect to air. If you are writing refractive index of water, that means refractive index of water with respect to air. But when you write refractive index of glass with respect to water, so that will be mu g w is equal to mu g upon mu w. So, see here, refractive index actually defines optical density of the medium, but do not get confused with the optical density and mass density. Mass density is actually here the mass per unit volume, but a optical density is not that one. It is entirely different with the mass density. It is not necessary if any object has the mass density higher, it will have also optical density higher. So, now this is about the refractive index. Now, we will do here the refraction of light through the glass slab.